Okay, so here's uh, here's the next thing we're gonna be addressing, hopefully this week, if we can get the block straightened out. Is we know that there's already been a recall back in the 50s with this engine. One of the issues was oversized oil jet, and there was a mechanic's note from the engineers that some of the pistons that were manufactured for this engine had a different head thickness, which would have changed the weight of the piston. So we know the engine's been through rebuild, and we suspect that one or two of these pistons may be heavier than the others, which has contributed to the engine's failure. So we're just going to do a quick weigh-in. I don't know if you can see those numbers there. If you can't, I'll call them out. So here's the piston, the first piston, and it weighs 15.6 ounces. All right, so we'll take the second piston, and it measures 16 ounces. So that's kind of close, but that's a little bit heavy. But here's the number 3 piston, and we're gonna weigh it, and it's 17.2. So the first piston weighs 15.7. So let's tare that, and let's put the heavy piston on. So we're 1.5 ounces heavier with this piston. So we know that this engine probably got mixed up in the piston swap back in the 60s, because it is a heavier piston. So we'll be addressing that with the new pistons and make sure everything's obviously up to weight. So we'll zero this out. Now we're going to take a look at the connecting rods. So this is rod number 3, and it weighs 31.9 ounces. All right, here's rod number 4, and it weighs 32.2 ounces. Rod number 1 weighs 31.8, 31.9. And then the last rod weighs 31.9. So we've got a couple of issues with the connecting rods. There, some of them, we got one of them that's kind of heavy. So with understanding that, we'll address the weight of these rods. We'll address the straightness of the rods. We'll address the concentricity of the rods. The other major concern that I've already found, it's not really a major concern, is that these engines had kind of a weak oil system on them, and the engineers, when they designed this thing, put an oil hole right in here, and it's a hole that's approximately 45 to 50 thousandths in diameter. I mean, it's a tiny hole. And the idea was that when oil comes through the crankshaft, that through the lightning hole, it squirts oil up onto the camshaft through this little bitty hole here. So, you got to check that when you get ready to build one of these things and make sure that they're not stopped up. And sure enough, rod number 1 was, plugged with debris. So, understanding what the crankshaft grinder told us, we don't really know. We know that this engine had some issues, and now we're starting to see why. So we'll get all that addressed hopefully this week, and you know, just stick with the videos, and we'll address one problem at a time, and then we'll move on to the next issue. So so stand by. Okay, so this is going to conclude the first part of this process, and I know that the first video is kind of boring, but we'll move on into the actual build. But I just wanted to let you know, the friend of mine know that, hey, this is how we do things. This is why we do the things that we do, and just bring him along during the whole process so he can see how this takes place, and why we do things in a certain order. So stand by for the second video. It'll be coming out in a couple of days, and we'll get into some of the machinery and actually getting this engine back up, getting the pieces and parts back up to snuff. So hopefully in a month or so we can hear this thing run. So when the video series is over and it goes back in the Jeep, obviously I'm going to take the camera over to where the vehicle's being stored, and we'll post a video of the mechanic driving it and you know, testing it out. So it'd be kind of nice to see this old girl run again and do what she was designed to do. So that's all for now. Stand by for the second part, M38 Go Devil Part 2, NMC. Okay, so this is the next video, I guess, part number 3, and we're gonna go ahead and break these connecting rods down, and but before we do that, we're gonna do a quick inspection on them and kind of see, you know, the condition of them. So in the previous video we discussed the oil hole located in these connecting rods, and it's just not going to be possible for me to get the camera in there to see that small of a hole. But I will stick a number 57 drill bit in it to see if any of them are stopped up, and let you see where the drill bit, you know, the alignment of the hole. So we're just gonna take our drill bit and obviously just slide it down in the hole like that, and that one looks pretty clean. And we'll do all 4 of these real quick before we get into the breakdown. This one looks pretty good. This one here is a little bit stuck. Yeah, let me get you in here on the camera so you can see what's going on here. So you can see where the drill bit goes through, and I'm gonna push this drill bit through. You can kind of see the crud that's coming out of that hole. So that's the number 1, and it was plugged. So we'll make sure we get that good and clean, because that had to have contributed to the bearing failure and the damage to the crankshaft. Okay, so typically what I like to do with connecting rods, because there's so many surfaces that need to be addressed, is the first thing I'll do is measure the bore and see if the bore registers with what is in the actual manual. And then I write all this information down on a chalkboard for each individual rod, so I can see the actual specifications and see what the actual rod is measuring. So what I'm measuring for is I have a set of intermites here. Let me show you these. Some people use dial bore gauges, some people use snap gauges, and those are all, you know, those are all nice things to use, but this is quick, down and dirty, and it gets down to the 10th. So, you know, I'm all about, you know, being accurate and being and doing it fast. So, so typically what I'll do is we're looking for the bore size. We're looking to see if the bore is tapered, and then we're looking to see if the bore is out of round. And the way that I do that is I just stick the inner mic inside the rod, and I get on one side of the journal, and I'll record that number. Then I'll rotate, I don't know, 60 degrees, and then record that number. Then I'll move over to the back side of the rod and repeat the process. Each time I record those numbers and compare it to what is in the actual TM. So I've done all of this off camera, so I don't bore you to death with these measurements. But we're going to take a look at them on the whiteboard so you can kind of see what the condition of some of these rods are. Now I think you can see that. Okay, so we know we have some major issues with rod number 1 from the get-go because of an plugged oil hole, and possibly because of a missized oil jet from the factory. So we've got our numbers on the board. I want you to take a look at number 1, the number 1 connecting rod. So over in the left-hand corner, I've got the specification required in the book. So the rod journal diameter can be no less than 2 inches 43 thousandths and no more than 2 inches 44 thousandths. So take a look at rod number 1. Now I wrote 2 measurements up there because one's on one side of the rod and the bottom number is on the other side of the rod. So rod number 1 measures 2 inches 45 and 2 inches 46. So we know that that rod probably got a little bit of heat. And rod number 3 is pretty much the same thing. I mean, it's 5/10 off, but you know, number 2 and number 4, they're just a little bit out of spec. But you know, we're gonna do all the rods. We're not gonna do just 2 of them. Over in the other column, you see an OOR column, and that stands for out of round. So I'll make 3 measurements with the inner mic at 3 different degrees inside the rod, and record those measurements, and that'll tell me if the rod is out of round. So if you look at rod number 1, it is 4 thousandths out of round. Now the maximum allowable out of round is 2 thousandths in the TM. So we're 2 thousandths over specification. The rest of the rods meet the specifications for out of round, but rod number 1 and rod number 3 is also tapered. So in other words, one side of the diameter is bigger than the other side of the diameter, and we'll correct all of this out on the rod home. But you know, it's just nice to be able to see the numbers so you know the actual condition of the rods before you go into the honing process. So what we'll do is we'll break these connecting rods down into pieces. We'll remove the cap from the connecting rod, pull the bolts out of it, and then we'll move out to the grinder, and we'll grind to specifications. So stand by for that.